All right, good afternoon. Welcome back to Elements of Calculus 2. We are continuing our test inventory for test number 2. So we're looking at problem number 3b here, which says we have 3x squared plus 2y cubed minus 18xy plus 42. We have to find minimums, maximums, saddle points, and all of that fun stuff. So the first thing to do, take a partial derivative, right? Can't hurt. So we're going to say 6x, partial derivative with respect to y is going to be 0, minus, and we have minus 18y here. We're going to set this thing equal to 0. Okay. Partial derivative with respect to y. The x's is going to be 0. We're going to have a 3 times 2, which is 6y squared, minus 18x is equal to 0. All right, so this isn't too bad. So we have x equals some stuff with y's in it. Let's see what we end up with. So let's go ahead and work through this equation. So we're going to say this is divide everybody by 6. So we have a y squared. 18 divided by 6 is 3. So we have minus 3x is equal to 0. Y squared is equal to 3x, or x equals y squared over 3. Like, why would I do that? Well, when we've got this equation that we solved for, right? We're going to go ahead and plug it into that equation. But I don't have a y squared, I only have an x, right? So let's go ahead and see what happens. So my y squared over 3 is equal to x. Let's go ahead and say this is 6. I've got a y squared over 3 minus 18y is equal to 0. All right. So the squared's just with the y. So 6 over 3 is just 2. So I've got 2y squared minus 18y equals 0. Let's go ahead and solve that. Could I factor out a 2? I sure could. We'll divide both sides by 2 or multiply both sides by a half. And we have y squared minus 18 divided by 2 is 9y is equal to 0. Careful. We have y minus 9 equals 0. So we could say that y is equal to 0 or y is equal to 9. Okay. Now, we still need to know what x is, and we know that x is equal to, I believe, yes, we have x is equal to y squared is over 3. So when y is equal to 0, so is x. And when y is equal to 9, we have 9 squared, which is 81, divided by 3. So we have x equals 81 over 3, which is equal to 27. Okay. So the points that we have here, x equals 0, y equals 0, we can go ahead and summarize that as a 0, 0. We could also summarize this as a 27, 9. Okay. And those are the points that we happen to have. The next thing we have to do is we need to know if these are minimums, maximums, or saddle points. So, of course, the next thing to do at this point is to take partial derivatives again, because I want to know what fxx is, and we'll go ahead and get what that is. So let's see, fx was equal to 6x minus 18y. fxx is just going to be 6. fyy, so I can go back up to where's my fy, and we can go ahead and take our derivative with respect to fy again, okay, with just the derivative of y, and we end up with h12y. Okay. fxy, so we're going to look at our fx rather, and say take the derivative with respect to y. We could look at the derivative with respect to y, take the derivative with respect to x, and both times we get negative 18. Okay, so again, we're going to say, okay, we need fxx, fyy minus fxy squared, and we're going to see what this actually turns out to be. Okay, and the first thing we'll do is we'll say what happens when x is 0 and y is 0, because that's the first point that we have to go with our values here. So we'll go ahead and say, by the way, x and y are both equal to 0. Okay, so we can go ahead and type out what's going to happen here. fxx was just 6, doesn't care about 0. fyy was just 12, and we're going to subtract off 18, negative 18 squared. Okay, 6 times 12, that's going to be 72. I think 18, that's going to be something like, I'm going to say 3 something. right? So we can just go ahead and say 18 squared. There's things I used to know. Um, let's see here. Indeed. And that's, yeah, 324. That sounds about right. Minus 324. 72 minus 324 is going to be less than zero. So we know that one of the values is less than zero. Great. Um, the fxx in this case, not that I think we really need to know, but fxx is going to be 6 times, it's 6x. So this is 6x. This was xx. So we could say that at zero, that this was also equal to zero. Okay. So let's see what happens next. So when I plug in, what's my other point? Is 27 and 9. X is 27. Y is equal to 9. So let's see. What is my fxx? That's just 6. My fyy, that was 12y. So we're going to have 12 times 9 sitting here. Okay. Minus the 324. And let's see what happens. And again, I'm not going to know what this is. So we have 6 times 12 times 9. So 6 times 12 times 9 equals, and we got a 648 sitting here. 648 minus 324, that's positive. Okay, what is my fxx in this case? fxx is still 6, so it's positive. Okay, so we'll just hold the thought for that one, and we'll just go through over here. We'll say, okay, what is the values I really need here? So for my d is less than 0, that was in the first spot because it was 72 minus 324. That is definitely lower than 0. So that is 0, 0 is a saddle point. Okay. And then what's the other one we have to deal with is my d was still less than 0. Was it less than 0 or is it more than 0? Okay. Sorry about that. I think d was, mm, okay. Yeah, fxx was still just 6. Yeah. Okay. Oh, okay. Um, I think we're looking at the next one down here. So it was, there we go. 648. It was greater than 0. Okay. Sorry. Lost my moment for a moment. That is going to be a relative min or a relative max, depending on what fxx was. Since fxx was positive, we have a relative minimum. So we have 27.9. This was a relative min. Okay. All right, so these were our 2 points for this of interest in that case. So that's how you pretty much do a problem like that. Okay, substituting, taking partial derivatives, solving the two equations, and then checking out what the determinant's going to be. That's pretty much how you're going to do every one of these problems. All right, so I'm going to say thank you very much for watching, and I will see you in the next video.